Well, good morning. Welcome back. Next video in this series, we're gonna finish this unit that we built last time. So we had the 5-port switch fitted, and that's working. Now we're gonna have the 5-volt row done. Because once the 5-volt row is finished, then we can start powering up the rest of the 5-volt equipment we want to add to the system. So what I've done in the meantime, and these wires are very short, it comes with this equipment, is I've okay, let me first run through what we've got here. So we've got our it's quite warm. We've got our display. So it's voltage and current display. The wiring on the wiring diagram is not that great, so I'll go through you guys with what needs to happen here. Then I've got a 42. It's a variable voltage regulator, so can take up to 40 volts input. We've got our 24 volts input, and it's 5-volt output. I've set it to 5.2. Then we've got, let me just turn this around. We've got a USB connector. This one I just took an old motherboard and took a grinder to it. I literally ground it, cut the PC board out, drilled 2 holes, and actually grounded off all the tracks as well. And that actually works. So I've got a, for to test, got this lithium battery charger on it, as well as a Raspberry Pi. So we now at the moment, it's 5.12 volts, we're drawing 0.23 amps. Now the spec on this says we can draw 2 amps continuously, and the specification on the chip itself is we can go up to 4 amps. This has been running since yesterday, and it's actually still quite warm for only 0.28 amps. This is quite warm. So what I'm thinking of doing is adding a heatsink, and these small heatsinks to it. Unfortunately, there's no space on this board to add it, so from the Pi shop I normally buy these the same pads that you put on the Raspberry Pi for heatsinks. I'm gonna cut a small piece out and just stick it there and put the heatsink on it. So that will be in this video as well. So what's next? First we will need to mount all of this and then extend all this cabling, because this cabling is a mess. So what we will do is 3D print a unit. I'm thinking of having enough space to have 2 of these units fitted. I'm also thinking of, seeing that it's getting quite warm, having a fan on this unit. I'll see how we're gonna incorporate that and get that done. So next line of business is 3D print the stand or the fixture. That 3D printed fixture will go right to the back there. Also, we will fit the 3D fixture there. So that unit will get a heatsink on there. I'm thinking of adding this, something like that, that's short. So this is 24 volts in or 40 volts in, depending on how much you want. I need to tap off on this side for this red wire. Sorry for that. This red wire, that's to power the screen. Can't really zoom there. Okay, so that's the powder screen. Then the thicker wires, and this is where the wiring diagram is very unclear on the colors. So the thicker side is your load side. So you've got a couple of wires there. That is to run your load. So the red wire is actually your positive monitoring, so your display, the top one. And then your black wire is your negative, and your blue wire is your load, a negative load. So it's a negative load side. If you can see on that side, what we've done there is sorry for that, let's just zoom in nicely. It is. So because ground plane is ground plane, we've got the blue and the ground plane. And at the moment, only those set of USBs are running. So we'll clear all of this up, make it neat, and install it back. Let's get off to the 3D printing. Well, the 3D print is done. I've put some spacers at the bottom already. Reminder, all of this is on the Thingiverse account. Link will be in the description if I remember, but the series have a link to the Thingiverse account as well. Okay, quick overview. So what we've done, what I've been thinking about is the unit itself is getting quite warm. And I did say we're going to add heating to it. But the entire board is actually for like we say, we're still running at point, can't really see there, 0.3536 amps. I mean, if it still need to go to about 2 amps, it's going to get really, really hot. So what I've done is I've used these on standoffs, and the idea is that we will be pairing okay, so we have a fan at the bottom, and then the two rails will sit on top. Now, since this is a 12-volt fan, yes, you get it in 5 volts as well. You take it right away. But I don't want to preload the 5-volt rail more than what's needed. So what I'll do for now is add the second unit on this side and create a 12-volt rail that eventually I'll make a bracket that side or fitting that side for 12-volt outputs. For now, I'm just going to bring it back into the 12 volts. So we'll on this side have 5-volt rail and then 12-volt rail on that side, or vice versa, doesn't matter. And with due time, depending on what's happening, I can print another full unit, move it down, and then make the top one only 5 volt and the bottom one only 12 volts, and then have the fan run off to 1. So the task now would be to put turning power off of everything and start reassembling all of that over to this. Like with the mains video, we're just gonna time lapse it, and I'll see what songs I can get to add to it. Not songs, just some background music, whatever. And I'll get back to you as we go along. Just before I go, I've made changes to this board that's on Thingiverse in any case. So this is going to sit a little bit more off center. And what I've been thinking about is you need to force the air in directions. At the moment, the air is just going to bypass. It's going to go up and just bypass out again. Just bypass out. So I've made a sort of a wall on both sides on a later module. What else did I change? I think that's the only thing I've changed is adding this wall instead of having this here to secure it. Let's zoom in better. This section. Yeah. So instead of having that, I've just made a permanent wall on the sides. I want to force the air in and then over the PC board or underneath the PC board, those directions and this directions out. Right. Let's start assembling. See what we get to. It's fighting me like mad. Don't know if it's a bad screw or what, but it's fighting me at the moment. I have to open up the hole slightly. So something I need to carry over to the model as well before I upload it to Thingiverse. Oh, that one is in place. So we've got a fan underneath, plenty of clearance. We've got clearance at the bottom as well, so it will be drawn in from the bottom underneath, and this one it will blow out this side, but on the one on the in the cloud in Thingiverse it will actually blow out this side. So let's just close this side, so it will just blow all the way through, trying to get the main heat sinks underneath because it's a surface mount pad, so it actually uses the PC board to dissipate heat. We will try to cool this unit off by cooling the PC board. entering the 5V line, I'm going to change this to yellow. Because everything red is 24 volts at the moment on the system. That's why you'll see the back here, black and red is 24 volts. So the yellow will be my 5V line. This is different from the PC power supply. PC power supply, I'm not mistaken, 12 volt is your yellow and 5V is your red. This is the wiring I've got. Unfortunately, I had a thick red one. You don't get that in yellow, I think, and therefore I had to go just change the colors. So this will be changed into yellow. So we've got our black, that is our negative. Then our load is the white, which is a negative load for this regulator. And then our voltage monitoring will be the yellow one for the 5V. And on this wire, which is the display power, is 24 volts, because the display needs between 12 and 20 and 30, I think. So this is red. This will make yellow then. While I'm shrinking this at the moment. So the next step is gonna be to get this loom together. I don't want a lot of cables running all the way through that side. Make it neatly, tighten it together. So I might quickly have a look if I've got a thicker piece of heat shrink, just to take all these wires together and make a single loom. Because that way, because on this side, no, if you, let me just give you guys over the eye up here. So if this display is fitted up here, I'll take it out. I can just unplug the wiring from the back, and that section should still stay at the back there. I would always also like to have this one as part of this wiring. So when we're at the back of this, we have the two cables plugging out, and that will go to the back. I think that looks good. You've got a nice loom. You can just put some small cable ties here and there. Good as I used to have on my desk. I'll get it again. So on to the next job. That's to fit it on this unit. You will also need to solder onto this unit still. That's something that hasn't been done yet. I also need to get the power in here, and this is these two on the side. I've pulled this additional 24 volts straight from the power supply, and those will be separately fused from this. I think we will jump onto this so we can. So if you look at this, you have a ground plane. Where is that? Do this for you. That's better. You have a ground plane which is obviously ground, and then I've measured with the multimeter, and these two 0 volts are actually connected to the ground plane as well. So that makes it easy. And then on this side, the 5 volts, because this is a dual USB, the 5 volts of these set are joined together, and the 5 volts on these are joined together on the PC board. So what I'm going to do is just get a better view of you. What I'm going to do is just connect the 5 volts from this side to the 5 volts on that side, and then out on the wiring. And that should then go to the yellow wire, yellow cable, that will also go straight into the controller. So that should go straight to here, to the V out, that side. So that side should be yellow. So there's going to be two yellows. The one yellow is to the USB port, and the other yellow will be for a voltage monitoring, which will be this one. So I think what we're going to do is put a dual crimp on there and sort it out that way. I think first things first, let's just solder this out. Get this one done. And then we'll tackle the next one. More light on it. Right. So these two should be 5 volts. I'm just going to short them straight on the board here. Those should be 5 volts. And then these are a ground plane. Technically that, you just look here. So see, the blue is our load, negative load. So that turned into white. So the white cable on this side. Got more than enough cable. Right. That's not gonna last. A proper joint here. That's better. Then we will need the yellow. Now thinking of, we'll have a smaller, thinner piece of wire from there to there. Here I've got thin wire. This is quite thin. So let's try this. Trying to let you guys see what's happening, but in the meantime I'm actually burning myself trying to get you guys in the view. Okay, so we've soldered that on. So now we will go over to this side and solder this on this side. So with this we also need this thicker piece of wire. Start a little bit shorter. Don't need all that solder to stick out. Let's get our soldering right. That's done. Now this yellow needs to go on there. Problem is if I put it on there, we might get a short. I will need to try to keep this as round as possible, not flatten it at any way. See how we're going to do this. Right, that's done. Okay, so that seems to be properly on. I don't like this very much. It's too much copper sticking out. So what I'm going to do is just make it neater. I'll cut this shorter. And let's put it back there. Like that a lot more. Before we move further, let's just confirm there's no shorts. And let's confirm so from this ground plane to the voltage, there's no short. Ground to ground, that's correct. And just for this argument's sake, the data side, in case there's a short, so let's take it from positive to any of the data points. I don't see any shorts to any of the data points. And this side as well, there's no short in data points. And then from a ground plane to the first negative, that's working, first negative working. Ground plane, there's no short anywhere. That's negative, that's ground plane. Oh, that's the data. Data. I'll double check from positive. There's nothing there, and there's nothing on those pins. So I'm happy with that. So we've got that connected, that's up and running. We're going to bring this closer. And I would like to get these wires, bring you guys a little bit higher up. So I'd like to get these wires out of here for now. So that loop bar fits neatly in there. That wasn't planned, it's just how it worked out. And these two wires go neatly through that opening, which was actually planned for those wires to go through there. It was actually planned for those wires to go through there. Just wanted to confirm this is out. So fan is on the side, there's going to be 12 volts, this is out to there. So I can get those in place. Get that done. I don't like these screws very much. But that's what I've got. I see there's a little bit of a mismatch. Something that I am going to make in future is a new PC board. Complete new PC board. This is just I didn't have time to make one from scratch. So make a new PC board with actually solder pads on this side that you can. No, the screw must be difficult. I'm just going to take this away from you guys. I can't work a little bit in my way there. Right. Taking a short break. Coffee. Let's move on. So, what I do have is actually give you guys a little bit. Okay. So, we have our connectors back at the back, and then the loom. So this positive will go to the bottom. So this needs to feed all the way through. Get this mess of wires out of here. So these two will stay roughly on this side. This one will go through to here. So do a double. We actually need to jump these two as well. And then on top, black will go in there. Yellow will be breached out on top. So let's get that done quickly. It might shorten the cable so you can actually make it neater. I think the white is going to be way too long, but that we will manage somehow. So for now, I'm thinking of making enough part for the back. So just gonna cable tie this quickly. Cut that off. No sharp edges. Oh, there's a slight sharp edge. Not anymore. Right. So let's start top. We want, let's see, maybe I can do it with two. Oh, we might be able to. So this will be voltage out. So you can fit you guys into that. Okay. Split these two. Let's get rid of the blue, black for now. So black is going to be a single piece of wire going in. So let's get rid of blue, that one. And with this, I actually hope this will fit in there. This has bitten me once before. It looks neat, but it doesn't always work. Just unscrew all these terminals. Make sure there's nothing blocking us from finishing. Okay, so what we've got is V negative on the black. And this black wire is the same black wire as on this board, on this block. Okay. Then we need to resolve the yellow one. But the yellow's got two wires that needs to be resolved. Pushing that through there. That will need to go to back there so we can have a nice wiring layout. That should be long enough. And this should be long enough as well. Make it a little bit longer so we can don't do that. Do that back slightly. And do this as well. It's slightly longer because we're going to actually twist them together and then take them through the my hands are sweaty at the moment. Let's see if we are lucky. Yes, we got it done. So let's grab that. And let's fit in tighten this. So we have our yellow and positive out, which is the positive to my USB as well as the positive that's now connected on the red on this side, which is my voltage monitoring. So this is voltage this is monitoring only, so voltage monitoring. And this will be 5V monitoring. So that finishes up the top section. So let's go down to the bottom. So this red wire is one on this one. So the documentation says you don't need to connect the ground if your monitored ground is negative. Gonna focus. Okay, so you do not need to connect this black wire, which is your display black, your display negative, if that negative, black negative is the same power supply. Okay. And if you take a multimeter and you measure between these two on the display, it's actually shorted out, so it's the same wire. So we will need to jump these two as well. And we need to link it to that cable as well. It's going to be very much interesting situation. So I think what we will do, because it's sitting like this, that cable will go to the first one for the 12V roll, and then we'll just jump to the 5V roll on this 12V roll on this one. We'll just jump to the 5V roll on that side. V in positive. This the red wire, which is the 24 volts, which is also going to the display. And then jump to this side. I'm thinking actually I should have taken the 24 volts from the 12 volt row. That should actually make, you know what, I'm going to do that. I'm going to take that from a 12 volt row. And the reason for that is I know the electronics in here is actually all 5 volt or even 3.3 volt. So there's a voltage regulator, small voltage regulator on the side here. And by taking 12 volts in here, I'm actually lowering the load on that. Remember in the beginning I said this was already quite warm when it touched it. I think it's going to be a better call to take this to a 12 volt row and let it power from a 12 volt row. The ground is still ground, still through. You just double check that. Confirm that quickly. So ground that side is ground this side. Ground that side is ground this side. So it should work. So I'm going to change that because it just makes more sense to have it actually on that side. Tell me in the comments if you agree with me. But that should actually look like this now. So let's do that. But before we're going to power anything up, I am going to disconnect this negative here for the fan. I've got no idea what this is set for. I haven't powered it up to see what it's actually set for. So I just need to remind myself to disconnect it again. Right, so we've got everything going to my display wired. Okay, we'll tie that down there as well, so it looks neat. All in place. Okay, this wire will go back in here into the feeding side. Voltage feed to this side. And this one I'm going to make a little bit longer as well. Simply because this needs to point to that cable. You know, if I had a connector, I think it would have been much better to tap this off a connector. Or rail at the back. That's something I need to actually think of next time. That's suitable. And then these two are going to be, you link that using I just don't think this is going to fit in that connector. To be honest, I think this is way too big. Yeah, it's not going to fit in there. So this one we might not be able to do this. A nice connector because it can't see that. But these screw down terminals are just not big enough. Can't fit in there. That's unfortunate. This one still fits. But that one fits. But I can't have this. So I will need to make another plan. One plan I can do is this board also have something I would like to do, but for now we do have soldering points on this board. So maybe connect the negatives and the positives that way around. Get this back out here. So giving a picture. So these boards have a positive soldering pad that side and a negative pad this side. So what I'm going to do is just solder that side to that one and bridge this one to this one. So no connectors will go in there or no wires. We'll just use this one, the standard connector, standard wiring, and that's it. Yes, I always make my solder points, my solder joints short. The reason for that is to make sure they don't use a lot of heat. The longer your point is, the more heat dissipation you've got, actually, which is unnecessary. And you just have a neater solder. And everything's done, you've got a neat my camera doesn't look that neat. This shows you my eyesight is really going south. Right, let's do the this is not long enough, is it? No, don't stretch it. This is very odd wire. This actually comes from the wire they cut off the display, and I'm not sure if it's copper or it should be copper, but it's dissipating heat at a massive rate. Because normally I could hold a wire like this and solder it, but this one my fingers are actually burning already. So very strange. It just eats up a lot of heat, or dissipates a lot of heat. Right, so that's done. So technically, if I measure now, from that negative, I should have all the way, yeah. So that means the negative is all the way through. And that's important because, like I've said, the negative for the display is the same negative that we have for the load side on the display. You know, incoming is that side, so that's fine. So everything left now is to let's double check. Terminate this point, plug it in, and start measuring voltages. So we're getting to the end of this, which for you might just be a couple of minutes. For me, it's spending 2 days on this, getting everything ready. The printing took another full day. Before I do that, I said I want to disconnect this black wire so I can make sure that the fan doesn't overrun. Everything else is fine, even if there's nothing connected here, so that should be still fine. I'm gonna I'm not gonna tighten this side for now. Should actually have given me more room on this, but I'll bring you guys closer. Then we're gonna plug this in as well as this side. I'm gonna try to let's wrap it up. Get back here. I think we're ready for testing. Guys, bets, are we gonna have smoke? Trying to look at all the wiring. Make sure we don't have anything funny. Let me just do another short test. So between positive and negative, nothing. That's fine. We will do we've done a test on those before we mounted them. Let's just confirm again. So I've got a negative here and that body should be negative. So that's wired correctly. So this side should be positive. Let's confirm here as well. So we will have so that's onto the power for the display, and then a load section for the negative should be there. That's fine. And the voltage monitoring should be yellow, which is that one, and then the other negative on that furthest point should be negative again. So far so good. So let's power up. You see that come up, we should see this come up, and then we can set the voltages correctly. Probably then once this is on 12 volts, we can fit the fan, and once everything is working, we will fit this into the position at the back. And we've got contact. So the first one, we've got 5.2 volts, which is what we've set. So we can also see the 5.2 on this side, 5.19, 5.2. But this one, we've got 20.2 volts. Now just imagine that fan was connected. It would have been quite a nice flying way. On this one, you can press the button and you'll see the incoming is 24 volts. So the voltage coming in from the power supply outside is 24, or you can't see there. Turn it a little bit. It's 24 volts, 27. Let's see, we'll turn this off. Let's turn the light off. Let's take the light away. Maybe we can focus now. That is on the side. So this focus, I think you can see there's 27.3 volts coming in. You press this top button again, it will go down to show 20.2 volts coming out. So we're going to bring that down all the way to 5 volts. By turning this little adjustment screw on the side, if I can see the screw. I just need to get some light back. Okay. So 13.1, let's take to 12.2. I've got it on 12.2 now. So what I'm going to do now is connect the fan up, and let's see what happens. Our display is still quite nice, stable. And the fan is running. So I at least should add some airflow to the system. Next question is our ports working? So before I plug in the Pi and blow it up, let's just plug in something that I am willing to blow up. Testing. Let's see if I can find it. Yeah, so we've got our lithium charger. So I'm just gonna right, so that side is working. Let's test the bottom one. That's working. This side working as well. And that side working as well. Okay, so with that connected in, see that doesn't draw much power. Let's plug this old Pi in and see what happens. So and we've got current being drawn, voltage is quite stable, and that's going to be the idea. So I've got my switch here for all the Pi servers. I've got two on this side, two on that side, and the mains is center will be my up-down link. And then on this rail, which then will be section of this, there will be two Pi's this side, two Pi's sitting this side, and this is in the center. So I will be able to see the current being drawn with these two. And anything that's happening funny, I should be able to see quickly. So this whole setup I can mimic. Further, I can pull this whole rail out with everything on it. And that's the general idea. So the next step now is I'm going to fit this to the back. So it's going to live here. Get you guys here. Yeah, that should work. Go, zoom, zoom. Okay, so it's going to fit in there. And this whole section is going to fit in front. So let's take the power off. This thing should from here on be quick plug and play. So that's for one issue that I might have, but I'll sort it out. So let's turn the power off and put everything back to where it should be. Okay, I'm not sure where this video stopped. I see I lost an entire video for some odd reason. So, guys, it's fitted. I didn't have any smoke coming out. So, just give you a quick run through. So I've got my connectors at the back, quick connectors. It's running all the way through to my rail at the back here. I've got my 5V rail and I've got my 12V rail this side. Eventually I'm going to make a PC board for that, which I'll put on the Thingiverse account as well. I'll use the same double stack USB ports like that. Like I said, this one I took a motherboard, attacked it with an angle grinder, and just cut it off and took all the components of it. So that's what I've done here, and I've got more than enough in motherboards to do the rest as well, but I'll make a dedicated board for this. Then let's twist it a little bit. We've got a 5.2V rail and we've got a 12.2V rail. Also, we've got inside there, you won't be able to see it. You can hear the fan. I'm touching the fan. It's running. These are actually quite nice and cool at the moment. Let's get in here. And I can feel some air movement bottom and top. This side I'll make another board with connectors on it. Come on, zoom. Okay, connectors on it that we can tap off there into this board. And I have multiple. Eventually I'm going to add fans on here. So there's another rail coming through here. And I would like to add 12V fans on here. I'm not sure how hot this is going to get eventually. So the best is I'm going to have a 12V rail and I'll put it on here. And like I also said, if I need more 5V, then I might add another board like this at the bottom. And then instead of having 12V on one side, 5V on the other side, we might change it to 5V on top, 12V at the bottom. That's something we'll get to. It's not going to be on this build. This build I'm going to finish up. But if there's any changes in the future, I'll bring you back. That cable there, that's for my main power supply, variable power supply. We still need to install, which will be this guy. So, back to what we explained. With the 5V rail now working, I'm going to start with the Raspberry Pis. One has already been built, and I went as far as completely build it. It's loaded with Open Media Vault. I've also written a JavaScript that there's a display that I've added, which I'll do on the next one as well. That shows the CPU temperature, the hard drive usage, hard drive temperature, CPU, there is a temperature percentage, all of that. That is coming into separate videos as well. So I've done it, it's working. I'll do a complete new rebuild on a new Pi out of the box, because I've learned some lessons while assembling it, that I'll show to you guys. On this side, I'll just bring my normal 2 Pis in. I'm not even going to do a video on this, you'll just see it appear. I also said the reason why I only have 2 screws in here at the moment is I might disassemble the entire rack again and make all of this dark gray, or the same matte black as this. I'm not sure yet if I'm gonna do that, but I'll see later. I did speak about the second rail at the bottom, and I've also gone ahead and I've printed this voltage monitoring. That's another video coming up. This one, there's not much to say about it. It will need to live on this rail here, or not rail, on this section here. There's no way to mount it, so this is another game that I'll need to sort out. Not sure if I'm going to make a full video of this or just explain and insert it. Yes, so guys, I'm pushing to get this done. Get it out. There's another project waiting for me, which is completely different from this. And I might do a short video before I get to this one, to the Raspberry Pi, because I'm needing information on that. I'm needing a lot of information on it, and I've done some googling and I could only find bits and pieces. It's an item that was bought in 1972. They haven't finished it yet, and someone has asked me to rebuild it, see if I can get it functioning again. So that's going to be an interesting one. It's not electronics, although there's electronics involved as well. It's more mechanical. It's a restoration project, but I'll show you that one when we get there. Guys, just please click on the like button, and apparently the subscribe button now is part of the bell button. So if you click on the bell, it drops down to subscribe. It helps me a lot, guys. Please, if you want to see more videos of these, click subscribe. This is only a vlog for myself basically, but I'm sharing what I've found on my, let's say, expedition, you can say it that way. I'm not sure the English word is at the moment. I'm sharing it with you guys, and maybe somebody wants to build something similar. And yes, all the models, everything is going to be in the Thingiverse account. Download it, guys, build it. I also have all the details and all the stuff available on the links below, so you can go look for it, buy it, use it. Guys, with that, I'm signing off. Be back in a holder here. With that, I'm signing off, and I'll see you in the next one.